Okay, now we're moving into our examples. So point P, xy is a point on the terminal arm of angle with a, point PXY is a point on the terminal arm of angle theta in standard positions. So we're going to determine the sine, cosine, and tangent of theta of the following points. I may not do all four, but we'll see where we're going. So if I draw an angle in standard position here, that's what it says. I'm drawing an angle in standard position, and on my terminal arm, we go through 0.34. So we go through 0.34, and really, what am I going to do? I'm going to determine sine, cosine, and tangent of the following points. I'm going to sketch them. So I know that sine theta is equal to my y divided by my radius vector r. Cosine theta is equal to my x-coordinate divided by my radius vector r. And tangent theta is equal to my y-coordinate divided by my x. So when we're able to take a look, now I'm just going to zoom in here. Now it's not a very pretty initial arm, so maybe let's just try to do another. There, much better. There's my initial arm. So my angle's in standard position. It goes from the initial arm to terminal arm, and there's theta. But I'm going to make a right angle triangle out of here. So this will be my x-coordinate, this will be my y. And my radius vector r is actually the distance from the origin to the terminal arm. And it's given by r squared is, r, not r squared, r is equal to the square root of a squared plus b squared. Now, you probably are able to spot out maybe, hey, isn't the r the hypotenuse of that triangle? Absolutely it is. So, and what we have going on is we have a triangle with side 3, side 4. Now, this is the famous 3, 4, 5 triangle, but pretend I don't know that. So my radius vector r will simply be the square root of my, I put a and b squared. It should be the x-coordinate squared and the y-coordinate squared. Sorry, I was thinking Pythagoras. So my x-coordinate is 3. My y-coordinate is 4. So the radius vector r is the square root of 9 plus 16, which is 25. So the radius vector r happens to be a rational number 5. Sometimes it's a irrational number, but this one we got, it's all nice and good. So very simply, now, sine theta. Now, I don't know what this angle is, but it just happens that the terminal arm goes through 0.34. But sine theta is equal to the y-coordinate, which is 4, divided by my radius vector r5. So sine theta is equal to 4 over 5. Cosine theta is equal to the x-coordinate, which is 3, divided by my radius vector 5. Tangent theta is going to be, I don't like how close that is. Tangent theta is going to be my y-coordinate divided by my x-coordinate, 4 over 3. And this might be a great point to maybe realize that's why we call these trigonometric ratios, because they are actually ratio. The sine ratio is 4 over 5. And I know some of you guys will want to reach out for your calculator and say, oh, the sine ratio is 0.8. Well, yeah, but it's 4 over 5, as is the opposite over the hypotenuse. Moving on to this next one. If we have a terminal arm of negative 3, 4, so I'm just going to draw my initial arm here. There it is. And then I'm going to go through this point, 3, 4, and there is my angle theta. So what I'm going to do to calculate the radius vector r? Well, the radius vector r is the square root of the x-coordinate squared plus the y-coordinate squared. But what I can do is I think it's a really good practice to make a right angle triangle to the closest x-axis. And there we have it. So now I have that this side is 3, this side is 4, and my radius vector is 5. Hold on. Base is actually -3. For some reason, we're going to start adding direction to what's going on. It doesn't change the math. So the radius vector r is -3 squared plus 4 squared. So my radius vector r is going to be equal to the square root of 25. So again, the square root of 25 is 5. So we end up with the same radius vector. And very simply, sine theta is my y-coordinate, is 4 over 5. Cosine theta is my x-coordinate divided by my radius vector r. So it's going to be -3 over 5. Now tangent theta is going to be my y-coordinate divided by my x-coordinate. My y-coordinate is 4. My x-coordinate is -3. So the tangent ratio of this angle is -4 over 3. Now this should make some sense, I'm hoping. Remember that the sine follows the y-coordinate. So the sine in quadrant number 2 has to be positive. Cosine in quadrant number 2 has to be negative because the x-coordinate is negative. And the tangent is really just the slope of the terminal arm. And what we're able to see here is that terminal arm has a negative slope. So I'm going to start here, continue on. This is the angle that I'm talking about. An angle in standard position whose terminal arm goes through -3, -4. So I'm just going to draw a right angle triangle, which helps me out. And my radius vector r is going to be 5 by using the same formula for the previous examples. Right? Where r is equal to the square root of the x-coordinate squared plus the y-coordinate squared. So sine theta is equal to the y-coordinate divided by my radius vector r. Cosine theta is going to be my x-coordinate divided by my radius vector r. Tangent theta is going to be equal to my y-coordinate divided by my x-coordinate. Now, I'm just dropping these really quickly, but what comes back is this over and over and over again. Maybe have those, if you're having a hard time following, maybe write those down and put them beside this video. All right. So now, there we are. It's a good policy that if you ever miss a point, just make the point bigger. There we are. So I'm talking about angles in standard position in quadrant number 4, whose terminal arm goes through 3 and -4. So just like before, we can calculate the length of our radius vector, and here it's going to be 5. And I can make a right angle triangle out of there. This is 3. This is -4, and my radius vector or my hypotenuse is 5. And this is, there we are. It's all over the place all of a sudden. There we are. So my sine theta is my y-coordinate divided by my radius vector r. My cosine ratio is my x-coordinate divided by my radius vector r. And tangent theta is my y-coordinate divided by the x-coordinate. In quadrant 4, sine is negative. Quadrant 4, cosine's positive. Quadrant 4, tangent's negative.